Okay, thanks everyone for coming to my talk. I think we're getting started. So, as you can see, this talk is titled User-Friendly Phishing-Proof Two-Factor Authentication with WebAuthn. And also why two-factor authentication is different this time. So, let's get started with some audience engagement. Who's familiar with at least one of these three things? WebAuthn, UTF, and FIDO. Show some hands. Who's familiar with at least one? Okay, that's like a fifth of the audience, maybe? Okay, keep your hands up if you are familiar with all three of them. It's like one hand, okay. And if you know the difference between all three of them, no hands, okay. So that's some of the things we're going to cover here today, along with a lot more about these things and why you might want to care about them. But yeah, a little bit about me. My name is Emil. I work for Yubico as a software engineer, and I'm also one of the editors of the WebAuthn specification. And WebAuthn is, of course, the main topic of this talk. And just to get that out of the way, I'm from Yubico. We make YubiKeys. Some of you may be familiar with them. But they are not the main focus of this talk. The main focus here is WebAuthn, which is something much bigger. So what I'm going to cover here today is first of all, what is WebAuthn and why should you care about it? I will show you some demos of what the user experience looks like, what the API looks like, and what makes WebAuthn different from other kinds of two-factor authentication. And then go into a bit of how you can support it in your own applications, what you need to do, and how you implement it, and so on. And then cover some advanced topics like passwordless multi-factor authentication and attestation. And yeah. Maybe all of these words don't make sense yet, but I hope they will by the end of the talk. So let's start at the beginning with what is WebAuthn and why should you care? And I will start at the end and then we'll backtrack and get there. So this is where we're going. WebAuthn is a W3C standard for two-factor authentication on the web. So W3C as in World Wide Web Consortium, the web standards organization. And it uses public key authentication, which of course, is a very nice thing for security protocols to do because it usually means you don't need any shared secrets, and so is the case also with WebAuthn. It is phishing resistant and capable of multi-factor authentication, all within the same protocol. And yeah, so this is where we're going. And on the right there, you can see what the header of the spec looks like, if you want to read the spec. So first of all, let's get a bit of a demo of what the user experience can feel like with WebAuthn. And for that, I'm going to use everyone's favorite website, GitHub. And this is a sign-in page for GitHub, so I pre-filled my username and password. And now we go to the two-factor authentication step, and I get this option here to use a security key. And on my keyring here, I have a YubiKey. I plug it in, touch the YubiKey, and there we go, we are logged into GitHub. And that is what two-factor authentication can feel like with WebAuthn. So, yeah, that's a very quick demo of the basic user experience with WebAuthn. And well, now, maybe you're thinking, okay, that's maybe cool, but I already have like Google Authenticator or something like it, and it's not that much work to type those codes, so why is this a big deal? And to talk about why this is a big deal, we need to talk a bit about phishing. Because phishing, of course, is the reason we have all these kinds of two-factor authentication. But the problem is that not all kinds of two-factor authentication are equal. You may have seen headlines like these, that hackers are bypassing 2FA by annoying victims with push notifications. We have bots that can intercept one-time passwords in real time and use them to bypass them. And we have like lots of high-profile attacks that bypass multi-factor authentication in some way. And like tools like EvilGenX that can do this quite easily and are quite easy to deploy and use today. And they're like phishing toolkits, like phishing as a service is a thing today. And how does this all work? How do they bypass 2FA like this? So let's take a look at this recording from a colleague of mine, where we get a sense of what a phishing attack can feel like today. So again, we're on GitHub, and we have someone who's opened an issue in our repo And they give us some links to things to look at, and yeah, everything's fine. We can see what they're linking to and so on. Okay, now GitHub is prompting us for our password. Okay, GitHub does that sometimes, so sure. Okay, so who noticed that we got phished right now? Yeah, okay, that's quite good. If you didn't notice, keep an eye out, and the next time, and then I'll give you a hint for what to look for. Well, okay, so we got phished, so now we're going to go into account settings and enable two-factor authentication so that doesn't happen again. So, okay, now we're getting prompted for our password again, and this time it's actually GitHub. And remember what this feels like. So we're in the account settings, we can set up an authentication app. Let's give it one of the OTP codes, and we're good. We have two-factor authentication set up. So now let's go back to that issue and click some more links and see what happens now that we are safe behind two-factor authentication. So now we have one more link here, and again, we're getting prompted for a username and password. Okay, so sure, let's do that. We type in the username, we type in the password, and yeah, now we're getting prompted for the OTP code as expected, because we just set up two-factor authentication, and we got phished again. And a third example of what this can look like, and now if you didn't notice the first two times, keep an eye on the address bar this time. And this time, the page is already filled in our username. We just need to fill in the password and then the OTP code. Again, we've gotten phished a third time. And yeah, if we're not keeping an eye out, we're expecting to see, or we're seeing what we expected to see. So we might not even notice that we were getting phished here. And as a last example, this very much looks like the same page that we had on actual GitHub, where we didn't have the username field, just the password. So yeah, again, we type in our password and our OTP code, and we have successfully been phished 4 times. And maybe we didn't even notice, because this really looks like GitHub. So one thing we can do against this is to use the WebAuthn instead. So again, we're going to go into account settings and go into security keys and register a security key. And we're going to name it YubiKey, and then you see the same pop-up as you saw earlier when I showed you the login experience. And now we can go back and try one of these phishing links again. And we will see that, again, we need to type in our password, as usual. And now we're getting prompted to use the security key. And we do that, and we use the YubiKey, and it didn't work. Okay, so that's good, because we don't want it to work on a phishing site. And yeah, now you maybe notice that up in the address bar now we have not github.com instead of github.com. And that is actually why this doesn't work. And I will get back to a bit more why that is and how that works. But one of the examples of two-factor authentication that we didn't see here, that I don't think GitHub supports, but at least other sites like Google has it, is mobile push authentication, where you just get a push notification to a mobile app, and then you just press a button in the mobile phone to allow yourself in. And that is a little bit different, but it's really not that different either, because, again, we were expecting to authenticate. So if we get an authentication prompt, sure, we just press yes, probably, unless we're eagle-eyed and notice that, like, maybe an IP address is off or something. And even if you, as an attacker, don't have your victim actively trying to log in and pressing the notification, maybe you can just annoy them enough, as we saw in that earlier headline. And they might let you in eventually anyway if you just annoy them enough with enough push notifications. So all this is not to say that you shouldn't use 2FA, because any 2FA is better than 1FA. So do use what you can and do support what you can, but all of these other methods of 2FA other than WebAuthn have the same underlying problem, that they don't really solve the problem. And the problem is that fooling the human is enough to break security. If you can fool the human, then you have broken security, and you have their account and you can do evil things to them. And the traditional solution to this, of course, is we tell people don't do that, right? Just always be on your guard, never use any passwords, certainly never click on any links, and you'll be fine, right? That sound familiar? Yeah. And of course, that doesn't work. Because security genuinely is difficult, and well, people don't want to think about security. They just want to get their work done. I'm not saying they're stupid. I'm saying that they have better things to do with their time. They don't have time for this nonsense, and they have enough stress to deal with already. So it's our job as security professionals to give them better tools to make it easier to stay safe. But yeah, fortunately we have all these wonderful machines that can do all kinds of amazing things, and we can use the machines to do the hard security work for us. Because unlike fooling a human, fooling a machine is difficult. We just need to make sure that the machines know what to do. And that is what we do with WebAuthn. Because in WebAuthn we have a kind of built-in fraud detection, which is tied to what you saw earlier with the domain name. And that is really one of the major things that sets WebAuthn apart from other kinds of 2FA. So, as I said, we have these wonderful machines. In WebAuthn, we have 3 machines that we're going to care about. We'll go into how this works and everything. So, first of all, we have the Authenticator, which can be like a dedicated hardware device, like a YubiKey, for example. It could also be built into your laptop or phone or whatever device you're using. So it could either be a standalone thing or built in. And what the Authenticator does, just like an Authenticator app or something, it is the thing that authenticates you. And in the case of WebAuthn, that means it's going to generate cryptographic keys and then use those keys to sign challenges. On the other end, we have the server, which is the thing that issues those challenges and then verifies the signatures to grant you access into your accounts. And the server is just a plain old web server in this case. In the middle here, we have the client, which is usually a browser, but it could also be built into an operating system. And what the client does is, for one thing, it manages access to the authenticators. So the server doesn't connect directly to the authenticator, like a YubiKey, for example. Instead, it's abstracted behind a JavaScript API in the browser. And what that means is, for one thing, all different kinds of authenticators, like whether it's a YubiKey or built into a phone or a laptop or something over Bluetooth or whatever, it all looks the same to the server. So there's one unified API to the server, and the server doesn't need to care really that much about what exact implementation is under the hood. The client figures that out for you. And also because the client is managing access, and which means that the client can deny access to authenticators if it wants to. And one thing we have in the browser is HTTPS, which means that the client can authenticate the server. And that is the really critical part here, that the client can authenticate the server before allowing access to the authenticator. So that is what we do with WebAuthn. When you go to log in somewhere, you load a login page somewhere, and the login page is going to go to the server, get a challenge from the server. And then again, because of HTTPS, the browser can authenticate the server, check that the cert matches the domain name you're seeing in the address bar, and then it will send the challenge along with that domain name to the authenticator. And the authenticator can sign the challenge along with the web origin, the domain name of the site. And then that gets sent back to the server. The server can check that it's the right signature with the right key and for the right web origin, the right domain name. And if all that checks out, you have a successful login. So now if you do the same thing on a fake site, well, we're going to be on a different domain name, but for starters, the server isn't really going to see any difference. It's going to send you a challenge. But now the client is going to, as usual, use HTTPS to authenticate the server. And now the browser knows that this is a different domain name, this is a different address. It's going to send a different domain name to the authenticator. And the authenticator is just going to say, okay, well, I don't have a key for that site. So I can't sign this because I don't have a key. And then the login just fails right there. And that's what we saw in that earlier example. It just said, try with a different security key or something, because, well, the one we were using didn't have a key for the fake site. And even if you do somehow have a key for the fake site, maybe you've been visited there before somehow, well, you'll be signing the wrong origin. And the server can see that you've signed a different origin than what the server expected. So the server can boot you out as well. And that, in short, is how WebAuthn prevents phishing, even when other kinds of 2FA don't. And crucially, even if you as a victim don't notice anything wrong, because the browser can talk to the authenticator and decide together, okay, this is the site we're logging into. And even if you as the human don't notice anything wrong, the machines will notice something wrong. And that is what really sets WebAuthn apart from other kinds of 2FA. And as an example, a few years ago, Google reported that after they had started requiring security keys for all of their employees, for all of their internal Google accounts, they have seen 0 account takeovers on their employees. So they have hundreds of thousands of employees, and they had, in a period of like 1.5 or 2 years, 0 successful attacks. And it's not just that security was stronger, they've also seen that using security keys was easier and faster and more reliable than other kinds of 2FA, which means that as a result, they saw a 92% reduction in support incidents related to login issues. So even though they spent a lot of money on buying security keys for their employees, they estimate that they more than made up for that in just time savings throughout the organization. And even though this study was specifically about hardware security keys, WebAuthn is not just about YubiKeys, because WebAuthn is an open standard, and there are many other implementations as well. So today, this is built into Windows, macOS, Android, and iOS. So if you have any device with one of those operating systems on it, you already have this built in, and you can use this today without any new hardware needed. So that's the first part of this, the what is WebAuthn piece. So let's recap that quickly. WebAuthn is a two-factor authentication standard for the web, an open standard for 2FA on the web. It is phishing resistant in a way that other kinds of 2FA are not. And users love it because it's very easy to use. Like you saw, you just, if you have like a YubiKey, you just plug it in, touch it, no typing needed. If you have it built into your device, it's even easier. You just click a domain, or you just click a pop-up, essentially. And security folks love it because it's very strong security. So, next part of this is a bit of straightening out some of these many maybe confusing terms that we saw at the beginning, like UTF, WebAuthn, and FIDO. What does that all mean, and how do they relate, and so on? Because this can be a bit confusing if you're new to this. And there's also some history, and yeah. But let's straighten some of that out. So let's start with the UTF, because the UTF is where all of this started in 2012. UTF is short for Universal Second Factor. It was a protocol designed by Yubico and Google, and it was designed to be a phishing-resistant hardware-backed 2FA protocol for the web, much like WebAuthn. So it was initially developed by Yubico and Google, and then later contributed to the FIDO Alliance as a FIDO Alliance standard. And the FIDO Alliance is an industry standards organization. One of the main things that kept UTF back from being widely adopted was that it was only really supported by Chrome. Like there were Firefox extensions that made it work in Firefox as well, but out of the box it was only really Chrome that supported it. And UTF was also quite inflexible. It was designed to be small and not so complicated to implement, so they could get it out and working and get some deployment experience. And that's great for getting something out and working, but it's not very future-proof because it's hard-coded with particular cryptographic algorithms and stuff like that. But then in 2019, that's when we saw the first official release of the WebAuthn standard, which this time, instead of a FIDO Alliance standard, it's a W3C standard. And which means that as part of this working group for this standard, there were representatives from a bunch of big websites and also from all the major browsers. So this is now a W3C standard, and it has much better support in different browsers. Like all of the major browsers support this and are on board and are represented in the working group writing the standard. WebAuthn also is backwards compatible with UTF. So if you have an old UTF key, like maybe a YubiKey Neo, then you can still use that with a new WebAuthn standard. And if you have credentials registered on websites with UTF, then those credentials can continue working with WebAuthn as well. So you don't need to re-register your keys when the site upgrades to using WebAuthn instead. And WebAuthn also introduced a few new features like pins or biometrics on the Authenticator, and I will get back to why that is different from a password, for example, and also a thing that's sometimes called usernameless login, which means that you have a user ID stored on the Authenticator. And those two things combine into something you often called passwordless authentication, where essentially the user in the best case doesn't even need to type anything at all to log in. Just, for example, plug in a YubiKey and touch it and you're good to go. And then finally, WebAuthn is also a lot more flexible than UTF. It has extension points and a bit of crypto agility and stuff like that. So it's a bit more future-proof than UTF is. But most of all, the biggest difference between UTF and or WebAuthn is WebAuthn is much more widely supported. That is probably the biggest feature difference between UTF and WebAuthn. But other than that, you can kind of think of WebAuthn as UTF version 2 in a way. One more thing that sometimes makes things a bit more confusing is that UTF was two things. It was both the JavaScript API in the browser and also the low-level protocol for the communications between the browser and the Authenticator. And that low-level protocol has now been renamed to CTAP1 to make things a bit clearer. And UTF is being used for the JavaScript API, in the name UTF. Because with WebAuthn, we also saw a new release of that protocol, CTAP2. And WebAuthn, like I mentioned earlier, has many different backends, unlike UTF. So you can have old UTF keys or CTAP1 keys, like the YubiKey Neo. You can have new keys, like newer YubiKeys that support CTAP2 with some new features. You can have built-in authenticators into your laptop with a TPM or a secure enclave or something on a mobile phone. And all of these kinds of different backends are supported under the same high-level API that is WebAuthn. So WebAuthn, strictly speaking, is only the web API in the browser, like the JavaScript API. But there's another term which is often flying around, which is FIDO2, which essentially is a marketing term for the combination of WebAuthn on the JavaScript layer with CTAP2 as the backend, which has these new features like pins and biometrics and passwordless authentication. And in the last couple of months, there's also a new term flying around, the term passkeys, which is also essentially a synonym for all of this. A passkey might have some other connotations about syncing, like cloud sync and stuff like that, but it's also kind of a synonym for just a credential in WebAuthn. The terminology on this hasn't quite crystallized into something definite yet, but yeah, things are happening and this space is still evolving. But it's good to know that most of these terms relate to the same kinds of things, and in some ways, some of them are kind of synonymous. So to summarize this little mess here, we have UTF, which is an old hardware standard, later renamed to CTAP1, and also the old JavaScript API. And WebAuthn is the name for the new JavaScript API. And then we have CTAP2, which is the new hardware standard, and it's compatible with WebAuthn. And then we have FIDO2, which is a marketing term that means the combination of WebAuthn and the new CTAP2 protocol. So with that all out of the way, let's cover a bit of how you go about implementing WebAuthn support in your own applications. And I showed you earlier what the header of the spec looks like. I actually would recommend looking into the spec because we try very hard to make it easy to read and understand, even if you haven't spent a whole career reading internet standards. And if you still find it difficult to read, please do open issues on GitHub, because we do try very hard to make it unambiguous and easy to understand. But okay, so the main entry points into WebAuthn is these two functions called navigator.credentials.create and one more I'll get to. And things I want to highlight here is essentially you send it a parameter object. I'll get back to a bit more what's in that, and then you get a promise back. And then what this function does is going to create a new public key pair, and then the promise is going to return to you the public key, which you can send back to your server and store in your database. And once you've done that, you can call the navigator.credentials.get function. And that is going to give you a way to put in a challenge and get that challenge signed by the authenticator, and then the promise returns to you the signature, which you can send back to the server and verify. So these two functions are the main entry points into WebAuthn, and these are in JavaScript. If you want to go about implementing WebAuthn, you're probably going to want to use a server library to help you with the server-side parts of it, like generating parameter objects and verifying responses and all that. If you go to this site, WebAuthn.io, there's a good index of libraries for different languages. We also have a page on Yubico.com, developers.yubico.com, with some more guidance for developers as well. So because this is a Java conference, I'm going to be using Java for some demos today. And I will be using a library called Java WebAuthn Server. And there are others as well for Java, but this is the one I know best because I wrote it. So once you have a server library, you can call these two navigator.credentials functions that I showed you on the front end. And if you have a server library that does most of the heavy lifting, the front end part is quite small and simple. But then you need to get the result back to your server and store the keys or verify the results. And you probably will be using the server library to help with that as well. So now, let's dive into a bit of code. And I'm going to be using a demo project here. You can see the link to that on screen. So let's dive into some code. And first of all, let's get this started. There we go. Let's get some larger text on screen here. So first of all, let me show you this. Oh, right, I need to put that up there. So here's my demo application. We're going to start out just with a very simple, right, I need to create an account first. Just start out with a very simple application where we can just create an account, and then we can log out, and then we can log in again. Well, like so. Okay, so we have password authentication. That's all well and good. Now, let's add WebAuthn to this. And I prepared some code here for there we go, step 1. And get that started. And while that starts up, let's take a look at what that does. So here on the first thing you're going to notice that we've done here is we've added 2 libraries. First, this one, maybe I need this be a bit bigger as well. There. First, we're adding this server library called WebAuthn Server Core and this front-end library called WebAuthn JSON. And now we can dive into the Java code here. Let's see. Let's make this a bit bigger as well. And let's take a look at what we've done here. So we added a couple of API access methods to our front end, some front end components. We'll get back to those later. And let's see, we'll go down here, adding some config things. But most of importantly, what I want to get to is, right, actually here at the end, we have some database stuff. We're going to start out with a simple database with just a users table, and then going to add a table for WebAuthn credentials. So this is to give you a sense of the kinds of things you need to store in your database. We're going to have a user ID, a credential ID, which is an ID for the key, some metadata, signature counts, it's part of the protocol, and this part here is the most critical part, the public key. And we can see that in there as well. And then let's get back up here. We have our, let's see, up here I think. Here in our demo app, oh, let's go a bit there. In our, come on. That is not what I wanted. Let's just do that. Okay, there we go. In this demo application type or class, the main entry point into this particular server-side library is this class here, relying party. So we have this object we construct just like this. It's quite simple. We give it an RP identity, which identifies the application that we're, our web application. And I will show you what this looks like on the front end as well. We give it a database handle and set what web origins we expect to be logging in from. And then what we can do with that is we can have this start registration function here, which is going to simply call rp.start registration, and then we wrap that in some more response objects and then return that to the front end. So now if we go back into here and open the developer console and reload this page, we can sign back into our account. And now we have this here. We can add a credential. So what that is going to do, this is going to, first of all, call that start authentication that I showed you. And what we're going to get back is an object like this. So this is what this public key credential creation options is, what was being generated here by this start registration thing. And so we give that just a user identity, and this one actually doesn't do anything because it's just an empty object right now. So we just give it a user identity that we want to authenticate, and that is going to generate for us this object here. So we see there's a challenge, there are some public key credential parameters just specifying which algorithms we want to use. And here is the RP identity I showed you earlier. We have an ID, which in this case is localhost, and this is essentially the domain name that you're binding your keys to, your user keys. And then you can have a human readable name for it. But this is the most important part. And then here we're seeing the user ID that we sent in there. So we have a display name Emil and an ID, which is just some kind of user ID in our system. So if we do that again, we will see like there. We'll use a YubiKey again to do this. And then we have what we're sending back to the server is an object of this shape. So we again have an ID for this credential, and then we have some more binary data. And what happens then is we have this finish registration function here, which is going to essentially take this JSON response. Let's see, where are we? Right, going to take this JSON response and parse it into a response object, and then pass that response along with the original request into this RP object that I showed you. With this finish registration function. And what that is going to do is going to take all these binary data, unpack it along with the request that we have, check that it's the right challenge, that the signature checks out and everything, and then give you back a response. And then you can store this credential in your database. Let's take a quick look at what that looks like as well, just to get a sense of what kinds of things you want to store. So we have this metadata, the user IDs and everything. We get the signature count out of the result. And then most importantly, we store the public key in our database. So now we can log back out and sign in again. And let's clear this. And again, authenticate. And in this case, we have a very similar thing. We start by going to the server and getting this parameter object, public key credentials request options, which again is being created by a start authentication operation, which similarly just uses this RP object to generate a parameter object. We give it the username that we want to authenticate, and we get back this object with the challenge. And this allow credentials is a list of the credentials that you can use. And this is also all generated by the library for us. And then, in a similar way, what we're sending back to the server again is another of these credential objects with an ID and some binary data. And then back on the server side, we send that back into the library in this function called finish authentication. Parse the response and then get it out of our temporary, get the corresponding request out of our temporary request storage, and then go here. Just pipe these objects back into the library. We get an assertion result, which is going to tell us whether this was successful or not. And then we can grant or deny access. And let's also take a look at what this looks like on the front end, where we have this sign-in component. This is a React application. Let's see. Here we go. So we have this sign-in form, which is just, let's see, there I believe. Yes, no, there. The sign-in form is just pretty much a plain form, which has a callback that's going to give us back. In here in handle submit, it's going to give us the username and password that we enter into this sign-in form. And when that happens, we can go to our API, make this call to the server to get the request object. And that's what we're getting back here as this data here. And then we can unpack this data and get the request.public key credential request options, which is this one, and just shove that into the WebAuthn call. And you might see here I'm using WebAuthn JSON instead of navigator.credentials.get. Like so. And the reason for that is because, as you can see here, this is supposed to be a binary value, but because this is JSON, I base64 encoded it instead. So what that should look like is it should look like something like this. It's supposed to be a uint8 array value. So you need to do some processing in between to get it into the right format. And that is what this WebAuthn JSON library does for you. So you can just pipe these JSON-like objects in instead. Oh, sorry. And WebAuthn JSON is a library developed by GitHub. It's quite good and makes this a lot easier to work with. So essentially, you just grab the request object from the server, shove it into this to the WebAuthn JSON, and then what you get back is PKC here, which is this object that I showed you here, this one, and then you just send that back to the server. And yeah, that is, in short, the kinds of things you need to do to support WebAuthn in your applications. We can take another look at a diff here, maybe, just to get a sense of how much change this is. Yeah, a lot of this is the backend code for the database access and like wiring up all the HTTP requests and everything. But yeah, in total it's about like 1,000 lines of code in total. A lot of it is also the front-end components. So that's a sense of scale of how much you need to do this. So with that, let's get back to the slides and talk a bit about the more advanced topics that I mentioned throughout the talk. Because this was like the basic use case where you have username and password authentication, and then you add WebAuthn as a second factor. But one of the things I've been talking about is passwordless authentication. And one common reaction to this term is, well, if you're passwordless, doesn't that mean one-factor authentication still? And that would be the case. Like if we have traditional password 2FA, we have the password, we have the signature, we send both to the server and get them authenticated. So, well, if we remove the password, that would be passwordless, but this is not really what we mean. This will be passwordless single-factor authentication, as noted. But if we want passwordless two-factor authentication, well, okay, so I've been talking about biometrics. Do we send a biometric to the server? Also no, because that would be a terrible idea, because if we're sending our users biometrics to the server and storing them on the server, if we get a hacker in our database, well, now our users can never use biometrics again, because it's very difficult to replace your fingers and it's very expensive to replace your face. So what we do instead in WebAuthn is we're going to send a PIN or a biometric to the Authenticator. So, for example, to the YubiKey. And then the YubiKey will authenticate the PIN or the biometric and then send the signature as usual to the server. And in that signature is also an assertion that multi-factor authentication has been done. So the PIN or the biometric is never sent across the network. All that's sent across the network is a single bit flag saying, yes, this was two-factor authentication. And one more thing, that means that we, in the best case, don't need to have any secrets in our database. And we can still use two-factor authentication without any shared secrets. And then one more thing we can do is we can have the Authenticator also, okay, there we go. We can have the Authenticator also send a user ID along with the signature if we have the user ID stored on the Authenticator. And this is the second thing I've been talking about username-less authentication, where you have both the signature authenticating you and the user ID telling you who you are, all in one step. And those are the features that combine into what's called passwordless 2FA, where you have user verification, which is the abstract name for PIN or biometric or some other thing. It could be it could be a PIN that you enter into the browser that gets authenticated by the YubiKey, for example. It could be if the Authenticator has a built-in display, it could be a PIN that you enter on the actual Authenticator. Or it could be like a fingerprint or a face scan or whatever. All of that is abstracted under one single bit of information in the result to the server. And it's all called user verification. It's just a sign that something more than just possession of the private key has been checked. And the other thing I've been mentioning is called discoverable keys, where you have a WebAuthn credential that you can use without having first to tell the server who you are. Because one of the things that I've been showing here is in these, in these request objects, we've had this parameter here called allow credentials. And one thing that does is it tells the client which authenticators you can use for this particular authentication. Another thing it does is that in this credential ID is actually encoded the key for this credential. So in the case of YubiKeys, the private key is not actually stored on the YubiKey. Instead, it's essentially encrypted into this credential ID. And then when you go to authenticate, you get this credential ID back. The YubiKey can decrypt the private key from this credential ID and use that to sign. And what that means is there's no limit to how many credentials you can have on one YubiKey, because these don't consume storage on the YubiKey. But if we want the YubiKey to be able to just tell the server, hey, I'm this user, then the YubiKey needs to store the private key in memory on the YubiKey. And that is what's called a discoverable key. Namely that the client can just ask the YubiKey, hey, what keys do you have? Without having to first go to the server and say, hey, I'm Emil, give me my credential IDs, and then you can ask the YubiKey, do you have one of those? And what that enables is you can just have automatic identification. This is disabled by default because it might consume this limited capacity on the Authenticator. But this is a thing you can enable in your application. This was previously called resident keys, and that name still sticks around in the API. But the new official term is discoverable keys, but yeah, it's good to know that those are synonyms. So if you want to use Passwordless 2FA, you're going to be using these two parameters called user verification and resident key. Like I said, the name still sticks around in the API. And you can set those to 3 different values: discouraged, preferred, and required. And those values do what they sound like. And then on the server, like I told you, if you use user verification, you get this assertion of multi-factor authentication. And the way that looks like in the response is we have this, in here we have, there, right here. In the response we have this Authenticator data, which is a binary object, and it looks something like this under the hood. And one part of this is this flag right here, this bit flag, which is the UV flag. And if you have enabled user verification and everything checked out, that's going to be set to 1. But one question one might have is, why should you trust that? Because remember, there's an internet between you, the server, and the Authenticator. And, well, how do you know what kind of device the user is using to authenticate? Maybe it's just a homegrown browser extension. Maybe the user is just using pen and paper to do everything and it's just setting this flag to 1. That's not likely, but it's possible in principle. And that is where we get to the topic of attestation, which is a way for the Authenticator to prove what Authenticator model it is. And essentially the way that works is, well, you have the YubiKey or other authenticators saying, yeah, I checked a PIN or a biometric or something, and everything is good. I have performed successful 2-factor authentication. And then the server can say, okay, but why should I trust you that you're not lying about user verification? And the YubiKey can say, well, I'm a YubiKey. You know that YubiKeys are trustworthy. And the server can say, okay, but prove that you're a YubiKey. And that's what we can do with attestation. So it's a proof of what Authenticator model the user is using. And if you have requirements on the devices that you trust as a server, then this enables you to extend that trust. And similarly with the other parameters, this is another parameter in the API that you can set if you want this information. It is disabled by default. But if you do, what you get back in the response, I can probably show you as well. Yeah. No, wait, sign in. Let's do sign back in. Like so. And add another credential. There we go. And here. What we're getting back is a response with this attestation object. And what that looks like under the hood is something like this. And we have the same Authenticator data as we saw earlier. We also have the new credential that we registered. And down here, we have an attestation signature and an attestation certificate chain. And the precise format of this varies depending on the device. And that is also one of the reasons why you want a server library to manage all these different kinds of formats of attestation. Well, what that means is that you can do things like this. We can go to ubico.com.genuine, and on this site there's this verify device button, and this uses WebAuthn under the hood. And so I can plug in my YubiKey and touch it, and now Chrome is asking me, do I want the site to see what kind of device this is? If I press skip here, then, well, the site doesn't get to see what kind of device it is, because then you essentially get an empty attestation object. What if I do that same thing again? Come on, there. And allow this. Then now the website can see that, yeah, this was a security key by Yubico. And if I unplug that one and use a different one, the server can see that this time it's going to be a Yubico Neo, or YubiKey Neo. And this is using the attestation information in the attestation object to identify what kind of device this is. So that is what attestation enables you to do. And in some cases you might need this. Like, for example, if you're a bank, then you probably have an interest in knowing that your users are only using approved hardware. And otherwise, oh, sorry, didn't actually notice. But yeah, it's disabled by default, and we Yubico recommend that you collect this information and store it in case you need it in the future, but that you don't require it. And I'm going to need to speed up here quite a lot. So one of the questions I promised to answer was, are we ready to just get rid of passwords completely? And probably not, because support isn't fully 100%. Like if you have Linux, you don't have this built in, and so on. So you probably don't need. You probably still need passwords for most of your users. There's also issues with account recovery, like if you use your authenticators or you're locked out of your account. But you definitely can allow individual users to go passwordless. But yeah, that is all the time we have, I suppose. Yeah, I would have liked to take questions, but I don't think we have time for that. Yeah, and yeah, thanks everyone for listening.